Welcome to Francis Kelsey School. This is Pre-Calculus 11 Learning Guide 10 seminar on radicals, part 1. All right, just to touch on, we need to review the parts of a radical. Well, we have a radical is this sign that you see in math. Now there are components to it that we need to know. What's under the radical is, for example, 6. That's called the radicand. Okay, you'll see that referred to in the textbook. Then there is a number out in front, for example, the 2 here. We call that the coefficient. And the last thing is we have a little number sometimes up here, and that is the index, which tells us how many times we are timesing a number by itself to get into there. So often we see this in math, and it's the square root or the radical 9. There's an invisible 2 that is not shown, but it's just, we know it's a 2 there, which means what number times itself equals 9. And we know that to be 3 times 3. So the answer to that, the square root of 9, we know is 3. All right, so that's what the index tells us. It's these two numbers. All right, let's move on. Okay, topic 1. Okay, the first example, we are converting mixed radicals to the entire radical. So when we have a mixed radical, you will see a coefficient out front. It's mixed. Now, we want to change that to an entire radical. So that means the entire number is the radicand. So there's a quick and easy procedure for doing that. All we need to do is we know the index is 2. So therefore, we take the radicand, which is 5, then we times it by the coefficient to that index. So we get the answer 20. So it's a pretty simple procedure. All right, here's some try these questions. So you'll notice that some now have variables. So we'll go through some of these. All right, so let's look at the first example, A, on this try. All right, so we have the radicand, which is 3. We times that by the coefficient. And remember, there's an invisible 2 there. It's not shown, but we know it's a square. So we get out our calculator and we type it in when we know that 3 times 16 is 48. So the answer is 48. The entire radical is 48. All right, so let's move over to B. So again, it's nice to see the index, because sometimes they don't put it. So we know that there is a 2 there. So we take the radicand, which we know is V, and we can put a little 1 there, V to the power of 1. And we times it by the coefficient, which is 3 to the power of 3. And now we make it to the power of 2. So now we just do a little bit of exponent laws that we did back in grade 9. So we have a power to the power, which means multiplication, so that's 6. And now we have multiplication with these two powers. We know we add. So d to the 7th is your answer. All right, so let's try C. So we take the radicand. All right, we multiply it. Well, let's just put the index in. We multiply it by the coefficient that's in front. and it's squared because the index is 2. Now we just do a little bit of math. Remember, this 2 comes to that to make it 4 because 2 squared. And it comes to that, makes it s to the 4. And then we do some tidying up. Multiply these two numbers to get 12. Remember there's a 1 there. Now we have the powers with the multiplication. That means we add the powers. So s to the 5 is the answer. Okay, so let's try one. Now we have a different index. We can see there's a 3 there. So we have an index of 3. All right, so take the radicand, times it by the coefficient, and now it's to the index, and now we have a 3. So let's just do some tidying up. All right, we now cube 2, which was 8, and we times those two to get to 6. Now we just do some more tidying up, multiply those two to get 32, we add those two to x to the 7th, and make sure we put our index in our answer, because it is an index of 3. All right, so that's that topic. So let's move on. So example 2 now is simplifying radicals, so putting them in the simplest form. So now we have the entire radical is under. So we want to simplify it. So there is a prime factorization tree you can do, or the factor tree we did back in a few grades ago. So we can divide it 2 times 100 and work our way. So we have this, we have this, we have this, we have this. Those are our inlets. So we put the inlets all in our house. I call the house this radical. Now we have a cool program that is in your calculator that does this for you. It does your factor tree for you. So you will learn how to use that because it's a valuable tool. So I'll show you that in our next example. But we have it displayed here now, so here we go. So there's what we have. Now because the index is a 2 there, we are looking for groups of 2. So see those 2 2's? They group together. And I call this jailbreak. That's my way of breaking down radicals to their simplest form. Okay, because the index is 2, these two buddy up together. This 2 jumps on his back, breaks out of jail. So that's where it comes to here. Okay, this one now is eliminated. All right, then I see another group of 2, so they help each other out to break out of jail. This guy jumps on his back, breaks out of jail. So now the 5 comes out of jail. This guy's eliminated, helping. Now this 2 right here is all by itself. It has no buddy to break out of jail. So that's why you see him still in jail. Now all we do is we take the 2 and times it by the 5, and we get our answer 10. So here is, we're not going to do factorization trees all the time. There's a quick and easy way of finding an answer. And we have our program. So hit your program button on your calculator. So hit the program button. And then go to your Math 11. Punch in form. 4 is your prime factors. Okay, then n is going to pop up on your calculator. Now we're going to type in 52 because that's our next question here. So when you type in 52 and hit enter, you'll notice that a 2, and a 13 pop up. So what that means is they are in jail together. All right, so now once you have this displayed, we know the index is 2, so which means we're grouping these guys together because there's 2 of them, they pair up together. jumps on his back, breaks out of jail. This 13 is all by itself, so it stays in jail. And there's our answer. 2 root 13. All right, so let's move over to the next one. This 4 here is your index. It's a little low on this example, but it's an index of 4. Now, I'll show you the long way of doing it, but it's a good, easy way of figuring out. Because there's no coefficients, there's no actual numbers in front of that C, we can just write out there's 7 C's. So you got 1, 2, 3, 4, 5, 6. You got 7 C's that are in there. That's expanded. You don't have to do this every time, but I'm just showing you not the first time here just to get the idea. So now what it means is you have now groups of 4, not 2s, groups of 4 to break out of jail. So it takes 4 people. These 4 join forces, get together, and break out of jail. So the C now, only one C, there's only one group, break out of jail. Now there's not 4 left, there's only 3. So C3 stays in jail, and your index is 4. So there's your answer. All right. So now with the next question, we have a big number there, and our index is 3 now. Should be up a bit higher, but now we'll go to our calculator, type in on program Math 11 prime factors, and you should see when you type in 864, those are the numbers that pop out on your calculator. All right, so let's put them in jail. Let's expand it all. So we have 1, 2, 3, 4, 5 2s, 1, 2, 3 3s. Okay, so let's deal with the letters now. Okay, so how many letters? There's 4 M's. And they are 5 N's. All right. So like I said, we don't have to do these variables all the time, but you'll see. Okay, we have got an index of 3 there. So let's group our 3s. There's one group of 3, so 2 breaks out. There's a group of 3s, 3 breaks out. There's 3 N's, so an M breaks out. There's 3 N's, they break out. And we're timesing those all. Now, what's left in jail? It doesn't break out. Well, we have a 2 and a 2, so that's 4. And we have 1 M, and we have 2 N's. So now let's just tidy up this part right here. So let's just go over here. Okay, so we have 2 times 3 times M times N is 6M N. And left in is 4M N squared. So there is our simplified answer. And don't forget your index. It's index 3. All right, so let's move on to the next one.